Hi everyone, this is Dr. Katturajan from the Department of Geography, Tamil Nadu Open University. Dear friends, today let us discuss about the rocks and types of rocks and cycle of rocks. Then it's followed by fault and types of fault, fold and types of fold, and how it's happening, what are the examples, those things. So mainly we are going to see in this class, there are two topics. One is rocks and its types. The one more is fault, fold and fault. Okay. So let us start with the rocks. While we are studying about the rocks, what do you mean by rocks and what are the types of rocks? Rocks are naturally formed or simply composed of crystals of or particles of one or more minerals. There are many kinds of rocks and they can be classified in a number of ways. However, the geologists classify rocks based on how the rocks are formed. So based on the formation of rocks, these rocks are classified igneous rocks, sedimentary rocks and metamorphic rocks. Let us see one by one how these rocks are formed. What are the examples for those? First, igneous rocks. The igneous rocks are formed through the cooling and solidification of molten materials. See, when these rocks are formed interior of the earth, when magma forms, when magma getting cooling and solidification, then it's getting to compaction, then it forms igneous rocks. The major properties of these rocks are crystalline in texture. When these rocks comes over the surface of the earth, it's called lava. But when it's being in the inside of the earth, it's known as magma. These magma getting compact and cementation, then it's formed as rocks over long period of time. It takes over long period. There are two types of igneous rocks are there. Based on the chemical composition, we can say that it's acidic in nature and basic rocks. High proportion on the silica, less dense and lighter in color. This is called acidic based on the solidification. Then basic rocks are high proportionate of basic what is that high proportionate of basic rocks and dense, it's more darker in color. That's what it's known as basic rocks. Then based on their origin, we can call it as where it's located. Based on the location where it's under the surface of the earth, it's known as intrusive rocks or plutonic rocks. When it comes over the surface of the earth, it's known as intrusive rocks or volcanic rocks. Intrusive rocks or volcanic rocks. So these intrusive rocks are formed inside the crust. It's a plutonic or crystalline rocks are formed slower cooling process. It forms over vast area of plutonic rocks are called batholith. So in this picture you can see that this is laccolith, this is batholith. These rocks, when it forms over large area, very big in size, within the earth crust, then it's known as batholith. At the same time, when it forms near the surface of the earth, little small size in nature than the batholith, It's called laccolith rocks. When these rocks coming to the surface of the earth through the vent, through that pipe where the weaker section is there, then it coming top to the surface of the earth. When this goes almost parallel to the surface of the earth, in the weaker section of the earth, then it's known as sill. When it goes vertically through the crack, it's known as dike. So in this way, there are so many terms we are using while we are studying about the volcano that we can see in the later stage also. Now let us come again to the igneous rocks. There are two things based on the origin. We said that intrusive rocks and plutonic rocks. Sorry, intrusive rocks or plutonic rocks. For example, we can say granite and gyprus is another term of rocks. Then extrusive rocks are volcanic rocks. When magma comes to the surface of the earth, it's known as, what is that? Lava. Lava solidifies on the surface of the earth, gets cooled down and forms the rock. That's called volcanic rock. These volcanic rocks are formed in the different types: lava flows, lava sheets, lava plateaus. For lava plateau, we can say that best example, our Deccan Plateau. Basalt, one of the example for this. So this is what igneous rocks. How igneous rocks are formed, what are the properties are there, what are the types of igneous rocks with the examples. That's what we have seen in this slide. The next one, sedimentary rocks. Sedimentary rocks are formed through the agents of gradation, like wind, then what is that? Glacier, underground water, river. These are the moving bodies or moving things which carried fine and silt material from one place to the another place. It's transported to the another place and deposited somewhere else. So those deposition formed through the sedimentation process. Sedimentation is nothing but transforming of sediments into rocks through the compaction and cementation. The process of compaction and cementation is called lithification. The major properties of the sedimentary rocks are crystalline and layered in structure. They are both hard and soft forms of sedimentary rocks. Sediments, layer by layer, it's going on sediments. The fossils are formed in this type of rocks. What are the types of sedimentary rocks? Clastic rocks, chemical rocks, organic rocks. These clastic rocks are formed by the accumulation of older rocks. For example, we can say sandstone and shale. Then chemical rocks are formed by chemical participation of minerals and constitute in a solution. These chemicals, for example, gypsum, then bartice, and nitrates. So these kind of sedimentary rocks which consist chemicals are formed. Then organic and biochemical rocks. These rocks are formed accumulation of remaining of organics. When these sediments, these organic remains, organic matters goes under the high pressure, then the process of compaction and cementation, it forms biochemical rocks. For example, coal, limestone, and chalk. The next one is, before that, just we can see there. So what are the sedimentary rocks? Example for those things: conglomerate, sandstone, shale, limestone, gypsum, and chert. The next type of rocks are metamorphic rocks. These metamorphic rocks are formed through the igneous and sedimentary rocks get transformed into metamorphic. The metamorphism is nothing but when these igneous rocks undergoes through the climatic factors like high temperature and pressure, then these igneous and sedimentary rocks are converted into metamorphic rocks. For example, clay converted into slate, coal converted into graphite, limestone converted into marble, granite converted into gneiss, sandstone converted into quartzite, shale converted into schist. So these kind of reformation converting into another form of rocks called metamorphics. Those igneous and sedimentary rocks only converting into metamorphic rocks when it goes under the high pressure and temperature. Here also there are two types of rocks are there: foliated and non-foliated rocks. The best examples how it's look like those rocks also we can marbles. These non-foliated rocks is two. The foliated metamorphic rocks, see the difference. Okay. The next, these best examples for the metamorphic rocks are slate, schist, gneiss, marble, quartzite, and conglomerate, metaconglomerate. Then let us see about the rock cycle. How these rocks are converted into from one to another. See, igneous rocks. The igneous rocks are formed in the two ways. One is intrusive, the one more thing is extrusive. The intrusive rocks are within the inside the earth under the crust. When those area undergoes through the high pressure and temperature, it pushes to the surface of the earth. On the other hand, through the lava also it's formed over the surface of the earth and formed as rock. Those intrusive rocks over the surface of the earth, due to the weathering and erosional process, it transported from one place to another place and deposited as sediments here. These sediments are gets compact and cementation. When it gets under the process of compact and cementation, it goes down, that means inside the earth. Those sedimentary rocks, when it goes under the deep, the temperature and pressure are increases, then it's become a molten material or it's converted into metamorphism. These metamorphic rocks, again it's under the high pressure and temperature melting, it's becoming a magma, it's semi-solid in nature. Then when it comes to the surface of the earth under the high pressure and temperature, it's become goes under the cooling condition, then it forms again as intrusive rocks. So this is what called rock cycle. Intrusive rocks, then it's become a sedimentary rocks, then sedimentary rocks are converted into metamorphic rocks. These metamorphic rocks again it comes like a intrusive rocks, again the same cycle. So these are all it's happening through the high pressure and temperature according to the place where rocks are formed or where it's located. Okay. So once again, igneous rocks, metamorphic, sedimentary rocks, metamorphic rocks. These are the three major types of rocks, and how it's formed, what are the properties, and what are the examples for those things. Then another major thing in this part is rock cycle. Okay, let us go for the next part of this lesson is fold. What do you mean by fold? Rock fold. It's not simple things. Just to image huge type of rocks. In this picture also you can see that how it's look like. The fold is an undulating structure that forms when rock or part of the earth crust is folded or bending. Say, for example, something may break, some things are get folded. So that means according to the structure and what it consists. So based on the rock constituents, it may get folded or break into two or number of pieces. When it's get fold, that process only now we are seeing. When it's get break, then it's called fault, that we are going to see later. So the fold that are upwardly convex are called anticline. You can see here how it's look like. This is called anticline. This is called syncline. Here what you are seeing is axis of anticline. In Tamil we can say it's known as Mugadu, the sharp edge of the hill. So this is anticline fold. This is syncline fold. Sinking. So this is concave slope. This is convex slope. Convex kind of slope or folding. Okay. In this folder, there are different terms to identify those things. We can see that limbs, see limb, this slope area. The limb are the flanks of fold. Hinge line, this is called hinge line. Where the flanks join together, this limb and this limb. These two limbs are joined together. That's known as hinge line. Then axial plane. The axial plane defined by connecting all the hinge lines of stacked folding surface. See, all the hinge lines. This is one limb, this limb, the another layer, another layer, another layer. These different two segments are joined together in the hinge line. This totally it's known as the axial plane. Fold are different kinds. There are different kinds of folds are there. Symmetrical fold is one in which the axial plane is vertical. That is symmetrical fold. See, this axial plane is in the form of vertical. Asymmetrical fold. See, this is axial plane is inclined. This axial plane inclined or tilted. The isoclinal fold. The isoclinal fold are, see how it's look like. The limbs that are essentially parallel to each other and thus approximately parallel to the axial plane. That's what isoclinal fold. Isoclinal fold. Then this is called overturned fold. The same way it goes little deep. Recumbent fold. This is recumbent fold. This is like a overfold. Again, it's going on bending like this. So these kind of how it's happening. This kind of fold. When plate boundaries are merged together, convergent boundary or divergent boundary. When two plates are merging together, the middle portion may get raised. That means two sides there is a pressure, it compressed together, then the middle raised. That's kind of fold. That's what fold. So it makes rocks get fold. So in this way, there are so many old fold mountains are formed. For example, Appalachian in North America, Ural Mountain in Russia, Aravalli Range in India. See that these mountains, major mountains found in all over the world, may get eroded over long time. So there may not be any sharpened peaks. The old fold mountains had their origin before the Tertiary period. That means 66 million years ago. Before that. So those kind of mountains over long period of time, when it undergoes through the process of weathering, then it's becoming short. It's not high peaks and sharps. So it's becoming short and turned. There are some mountains called young fold mountains, or it's known as alpine fold mountains. This is within the period of Tertiary, or 65 million years ago to present situation. Himalaya is one of the youngest mountain in the world. Rockies in North America, Andes in South America, Alps in Europe, Himalayas in India. These are the young fold mountains are found in the world where high peaks and valleys are present. See the difference between these two. Old fold mountains are short in nature. It's eroded topography. Sometimes it become a flat. But at the same time, where the young fold mountains are, it's having high peaks and valleys. This is a major difference between these young fold mountains and old fold mountains. Here you can see some of the young fold mountains where and all it present. See, Rockies. This is in North America, Andes in South America, Atlas Mountain in Africa, Alps Mountain in Europe, Caucasus Mountain in between the Black Sea and the Caspian Sea, Himalayan Mountain in Asia. So these are the major young fold mountains. Then let us see about the fault. What do you mean by fault? The fault is formed in the earth crust as a brittle response to stress. Generally, the movement of the tectonic plates provides the stress and rocks at the surface break in response to this. Faults have no particular length scale. If you whack a hand sample size piece of rock with a hammer, the cracks and breaks, you may you make a fault. See, when rocks are breaks into two or in break into small particles, that's known as fault. How it's happening? See, if you look at this map, you can see that how these faults are occur when two plates are moving apart from each other. The middle of the middle portion may get breaked. Here different kinds of breaking action. See these diagrams. This blocks moves this side, the another blocks moves opposite side. This is a kind of fault. And see here, these kind of things are happening in the divergent boundary. Both plates are moves apart from each other. Then both plates are moves get converged, moving opposite direction. That means both are converging. So when these action happen over the large area in the rocky structure, results breaking. This breaking is formed in a earth crust. That's what you have to understand. The next things, what are the types of fault? This is called normal fault. This is strike slip fault. This is reverse fault. This is an oblique fault. See, when the crust bend folding occurs, but when it cracks, then faulting taken place. Fault is a planar fracture in a volume of earth crust across which there has been significant displacement of blocks. Both blocks are merging together. See, earthquake and tectonic plates. These are the major things to breaking the plates or rocks. Earthquake results from the tectonic plates movement and occur at the boundary between the plates along the fault. The transform fault is a type of transform boundary called strike slip fault, where portions of crust move past each other horizontally. Since no crust is created or destroyed at a transform fault, it's called conservative boundary. You can see here how these two plates are moving apart from each other, and these two blocks are displaced, results fault occur. This is transform fault. This is what is known as fracture zone. Here you see this oceanic ridge get diverged into two parts. And recently the same kind of one cracks, that means one fault is occurred in Africa, that you are going to see at the end of this. These transform faults in the continental crust are known as fault line, since people can see the effect of earthquake that are produced from the buildup of pressure between plates at these boundaries. For example, San Andreas, Alpine, and North Anatolian faults. Dip slip fault. What do you mean by this? In a normal fault, hanging wall moves downward relative to the footwall. That means stationary blocks. In a reverse fault, the hanging wall move upwards. See, hanging wall moves upwards. Then reverse faults occur due to the compressive forces, where the normal faults occur due to the transile forces. You can understand by seeing these diagrams. When these two blocks comes down, these blocks remains the same. So the highest portion in between the two valley, it's called flat portion. It's known as karst topography. It's in Europe, you can see. In between the two blocks, the middle part of the block get down. Then it forms graben. This is what is called dip slip fault. Then the real example of Rift Valley, it's in Africa. This is the longest, very deepest Rift Valley over the world. In the world, this is the deepest and the longest. These rift valleys are formed through the tension causes the central portion to be let down between the two adjacent fault blocks, forming a graben or rift valley, which will have steep walls. East African Rift Valley system is the best example of this. Block mountains. Block mountains may originate when the middle blocks moves downward and become a rift valley, while the surrounding blocks stand higher as block mountains. The previous slide you might have seen that how it's look like. Plateaus. The surrounding blocks subside, leaving the middle blocks stationary. Such cases are found high plateau regions. Plateau is nothing but tableland. That means the other side two blocks are moved down or slipped down. The middle flat areas remains higher. That's what is known as plateaus. Oblique slip fault, a fault which has component of dip slip and a component of strike slip, is termed as oblique slip fault. Nearly all faults have some component of both dip slip or strike slip. Many disasters like earthquakes are caused due to the oblique slip. Now let us see a small video. Recently it's found how the rift valleys are formed. Just watch this. By this video we can conclude this portion. Yes. In Kenya, it's recently found that there is a large size of cracks over the surface of the earth. Almost they are saying that Somalia and half of Ethiopia, Kenya and Tanzania are expected to split Africa to form a new continent. That's what you are saying now. Kind of research is going on. These cracks are going on, becoming wider. If it is happened, then the Ethiopia, Kenya maybe apart from the Africa, it may form a new continent. Yes. So let us conclude today's session with this video. In the next class, we will meet again.